Hello everyone. Today we are going to discuss about the technological improvements, innovations in the manufacturing. So when we talk about, because actually we are discussing about the block 3, in which we will discuss about innovative manufacturing systems. So what are the innovative uh, technology or the innovative things that are being taken place in the manufacturing systems? That's we are going to discuss today. And in that we have 3 units which will talk about the technological innovations in manufacturing, modern manufacturing methods, as well as automation and robotics. So whenever we are thinking about the technological innovations in manufacturing, we are going to discuss what are the innovations that are being taken place in the manufacturing with the help of technology, and what are the new methods or new manufacturing methods that are used in the industry. And the next part is what is the role of automation and robotics in the manufacturing system that we are going to discuss today class. About these 3 topics we'll try to cover it. So for the first one is technological innovations in the manufacturing. Why? Because as the technology is taking the advancement, and due to technological advancements, it's compulsory or it's mandatory to have the change and to try to implement it in the industry so that it can progress in the market and it can face the competition in the market, which is already in dealing with the innovative things and giving competition to the manufacturing organizations. So in that first we'll try to discuss about the technological innovations in the manufacturing. So here when we talk about the technological innovations in manufacturing, it's about the sustainable manufacturing we can call, or sustainable manufacturing process, or sustainable manufacturing, or eco innovation, because we always try to have an economic eco environment and green environment. So what are the manufacturing, the technology advancements we are using in the industry that has to be sustainable, that should sustain the economy, and it should create eco innovation rather than destroying or disrupting the environment. So here we'll discuss about the, when we talk about the technological innovations in manufacturing, we discuss what is Industry 4.0, IoT, that is Internet of Things, intelligent robotics, what are additive manufacturing, what are advanced composite materials. This all we'll try to understand in the present session, and to know much more about what are the technological advancements that are being implementing in the manufacturing process. So let's see that. Whenever we think about any technological innovations in the manufacturing, because then manufacturing industry especially, the pace of production with means production rate with mass production. Why? Because technology has improved the efficiency, effectiveness, and also the quality of production. And there are many evidences stating the importance of uh, optimization and minimal global carbon footprints, because now whenever we talk about the sustainable development goals, because SDGs we are talking nowadays. Why? Because sustainable development we are moving towards the sustainable development. And so when you look at here, there are many evidences stating the importance of optimization and minimal global carbon footprints. Why? Because whenever we're talking about the sustainable development goals, in which around we have 27, in which it's always talks about the sustainability. So, and to reduce or to minimize the carbon footprints. So, how to reduce the carbon footprints? With the help of technology, and by using the technology, is it possible that we will look at that. So whenever we talk about the new technology in the manufacturing concern, Here first we have to discuss about the industrial revolutions. Why? Because whatever the major technological innovations that took place in the period of industrial revolution, that have brought a major changes, because the industrial revolution during that period, whatever the technology that has been introduced, that brought a lot of changes in the manufacturing industry, textiles, transportation, mining, and many other fields. And apart from that, industrial revolution had its impact on demand and supply ratios also, with the automations and mass productions. And this changed the whole world in terms of economy, their living standards, and they are major driving forces today where globalization and trade that are taking place. So the first industrial revolution was took place in the Great Britain between 1760s and 1830s, and this has marked a major inventions such as taking right from the steam engines, water wheel technology, and there are many more foundation that took place automation in the production line during the industrial revolution. So the great authors or the researchers like Frederick W.T. Taylor Scientific Management, Franklin and Lillian Gilbert Motion Study, these are techniques and these have highlighted the production line, especially Ford's production line, and design how they're interchanging parts in the products, and through which they're getting optimum resources, which is leading to lead time management. So when you talk about the industrial revolution and the implementation of innovation in the manufacturing industry, we have to talk all this point because these are bringing a great revolution to the manufacturing industry. Next, we have is concepts of sustainability in innovative technologies for manufacturing. So, what are the concepts that are there behind the sustainability in innovative technologies? That too for the manufacturing. So, when sustainable, because sustainability is the main agenda for all the government, for governments especially, because it's a major component for companies across the world. Why? Because when you go for the sustainable production or manufacturing, then we are going to reduce the carbon footprints. And here, the sustainability is all about little resources and maximum output. We try to use the little sources and give maximum output. And we have four pillars of sustainability under which we have, that is corporate social responsibility, economical, social, environmental, and human aspects. So we have corporate social responsibility, four pillars, in which the first one is corporate social, that is economical, social, environmental, and human aspects. So these all will be taken into consideration to consider whether it is sustainable and innovative technology practices or not. So when they are following all this, then only it will be considered as sustainability. So when we talk about the Porter's five forces theory, where innovation that lead to competitive advantage. So, and here this all are used: sustainable manufacturing process, energy efficiency, pollution and waste management, and sustainable manufacturing and eco innovation. These all are we are going to understand with the help of this sustainability. Now, next is sustainable manufacturing. Here, when we talk about sustainable man, because these are the which these are various aspects that are relating to sustainability and innovative technology. So we'll try to understand one by one what is sustainable manufacturing process, what is energy efficiency, what is pollution and waste management, and so on. Sustainable manufacturing and eco innovation. Next, sustainable manufacturing. This is defined as optimizing resources and maximizing output where there is minimal negative impact on the environment. So we try to, under this sustainable manufacturing, it will be like maximizing output and there will be minimum negative impact on the environment, and this involves conservation of energy and also natural resources. Many of the current technologies which are focusing on improving renewable practices in the manufacturing process. On this note, there are some major invention includes generation of electricity, solar energy, vibrations, tides, wind, etc. So these are all the new inventions that have been involved in sustainable manufacturing. If you take the renewable practices, and they're also having technological innovations to optimize the human efforts and create new disciplines and skills. So this is what means sustainable manufacturing means when we talk about the only conservation of energy. To take the energy rather than using more of power, we can go for the solar energies. Some option we have substitution through tide energy, wind energy. This also can be used rather than depending on only one. And also cradle to cradle. This all is one among new production chains which are encouraging new innovations in technology, and also it is becoming perfect definition for sustainable manufacturing. Now, when we talk about sustainable manufacturing process, so here production method, it is a series of steps that are followed in manufacturing a product. For example, sustainable production name mainly focuses on improving the production rate at very little utilization of non-renewable sources that are limiting the number steps while improving the product quality. So, in this perspective, technologies such as IoT, 3D printing, production line automation technologies are being used for better efficiency and effectiveness. And also we have blow fill seal technology, BFS we call it as. You can just look at here, it's a blow fill seal or BFS technology, which is used, which is utilized in manufacturing of four fluids, is a perfect example for limiting the steps in production. So these are where there we have some limitations which cannot stop that. Like this aseptic BFS unit forms the plastic containers. It fills the liquid and seals it in single production setup unit itself. So where they are trying to minimize with the help of the technology the production rate of 50, up to 15,000 units. There is zero wastage. So we are trying to minimize the human intervention, and also when we are trying to minimize the human intervention, it means we are trying to minimize the risk of contamination. Means when we talk about this example like BFSS seal, blow fill seal, where the technology fluids which flows, there we're trying to minimize human resources, means we are even trying to minimize the risk and also increase the quality. So the three steps which are forming, filling and packaging are consolidated into a single step and consumes comparatively very lesser resources. And many such innovations or inventions create on sustainable production process. Next, we have energy efficiency, pollution, and waste management. And here, the main aim of manufacturing company is to attain maximum possible production. So when we are talking about energy efficiency, pollution and waste management, the main aim of manufacturing companies is to attain maximum possible production and efficiency to increase their competitive advantage in the market. On this note, so when we talk about energy efficiency, pollution and waste management, uh, the main aim of manufacturing company is to attain maximum possible production and efficiency to increase their competitive advantage in the market. So on this note, recycling and usage of renewable resources in the production cycle plays very crucial role. And also, in the other hand, the world organizations are focusing on zero emissions and also development of renewable resources. AgriGold Private Limited has utilized agriculture waste in thermal power generation, means which is making cost effective and also trying to reduce the from the waste they are producing some other power generation. So which is making world organizations this is recognized and become a profitable idea also, because energy conservation and waste management are contributing to the cradle to cradle chain. So what is happening because of this technology such as AutoCAD, simulation software solutions, these have changed the dynamics of whatever designing, engineering, and planning phase of production. Sustainable manufacturing and eco innovation. So towards a green economy, innovation has long been it has seen as economic performance and social welfare. It also increasingly recognized as a significant driver of economic growth. And more recently, industry leaders and policymakers have also looked to innovation as the key to making radical improvements and also incorporate environmental practices. So, for example, if you take the European Union Environmental Technology Action Plan, it aims to accelerate the development of environmental technologies and eco industries. While the Japanese government uh, towards green economy, innovation has been seen as central to economic performance. And when we take the example of European Union's Environmental Technology Action Plan, it aims to accelerate the development of environmental technologies and it aims to accelerate the development of environmental technologies and eco industries. And while the Japanese government promotes the concept of eco innovation as a new field of techno social innovations that focuses on the environment as well as on the people. Even OECD also defines innovation as the implementation of new or significantly improved products, which may be goods or service, or it may be process or new marketing method, or any new organizational method can be used. So when you talk about innovation, this is paying much attention nowadays, and especially after post-COVID, also this has been gained a lot of attention because of some setback. Because as we have faced a lot of challenges during that period, so that period has made our country also to move to the new innovations, eco innovations, and make in India, and to have self sustainability and self independent or self dependent rather than on depending on some other nations. So that was the like initiation, and government was also promoting the concept to meet sustainable development targets while keeping industry and the economy competitive. So what had happened by this means apart from that, the Japan's eco innovation concept has gained a lot of importance and attention. We just look at here, the fields are they have taken technology, business model, and social system, and the targets are industry, social infrastructure, and personal lifestyle. And they are into the manufacturing industry. When we talk, that is meant by manufacturing as well as service and social infrastructure, energy or transportation or urban, and personal lifestyle. That's it. So when we talk about technology in the industry perspective, here we have sustainable manufacturing or innovation of R&D and rare metal recycling. And the service, we have innovative R&D. And when we talk about social infrastructure, innovative R&D, that is renewable energy, batteries, and when talk about transportation, intelligent transport systems, and a personal lifestyle, it was heat pumps. So like this, the eco innovation concept has been introduced. And when talk about business model, green procurement means business to business, green servicing, and services, energy services, or environmental finance, green certification. So they're all talking about green procurement, cool base, green finance, and social system. In social system, environmental labeling system, green investment, top runner program, So like this, we talk here, the total concept is about eco innovation. Whatever the innovation that has been taking place, it's talking about eco friendly only. And next is eco innovation, meaning and its dimensions. So it refers to any new invention or technology that significantly contributes to sustainable development. This could include innovations that reduce the impact of production on the environment and that enhances nature's resilience, that use natural resources in a more efficient way. So here when we talk eco innovation is generally the same the types of innovation it is. So I know any invention or innovation and technology that is contributing to sustainable development. So what are the facets of eco innovation? We have targets, mechanism and impacts are three facets of eco innovation. So when we talk about target, so here are the basic focus area on of eco innovation. These are products, process, marketing methods, organization and institutions. And eco-innovation in products and processes tends to rely on technology development or technological development, while eco-innovation in marketing organization and institutions release more on non-technological changes and mechanisms, which are how changes in the target areas are made, and they are trying to involve the modification of practices, redesign of practices, alternatives to existing practices, or the creation of new practices. So these are all the mechanisms. And when we talk about the impacts of the facets of eco innovation, which are how the eco-innovation affects environmental conditions. Their experience shows that more radical changes that are taking place in the methods, such as alternatives and creation, usually which will result in high environmental benefits. So you can just look at here. These are the three main facets of eco-innovation. That is, you can see here eco-innovation targets, and in that we have institutions, organizations, and marketing methods. And here, primarily non-technological change means where there is no impact or usage of technology takes place, and higher potential environmental benefits, but more difficult to coordinate them. When we talk about the process or products, here primarily there is a technological change, means when you take eco-innovation mechanisms, modification, redesign and alternatives, what is happening is there is higher potential environmental benefits that are more difficult to coordinate, because till a technology we can change, but when we go to the non-technological change, it is taking a lot of but it's very we can achieve higher benefits, but it's very difficult to coordinate and attain that. And sustainable manufacturing calls for multi-level eco innovations. So here innovations play a key role in moving manufacturing industries towards sustainable production. We can look at here conceptual relationships between sustainable manufacturing and eco innovation. And if you look at here, we have institutions, organizations, and marketing methods. That is on y-axis. That is when we talk about the eco-innovation targets and process and products. And when you take it on x-axis, here we have eco-innovation mechanisms. We have modification, redesign, alternatives, and creation. And when you're talking about this, if you just look at here, the first one is when we are moving to the sustainability, the first one is pollution control, cleaner production, eco-efficiency, life cycle thinking, closed loop production. Then comes the industrial ecology, which is related to non-technological changes. And these all till institutions where they all are the part and parcel in attaining or getting the what is the relation between sustainable manufacturing and eco-innovation. Then talks about the focus on current eco innovations. You can just look at your industry and company and association. So we have automotive and transport industry. That when we're talking about the automotive and transport industry, we have Toyota, BMW Group, McLaren, and Wave. And eco innovation example is BMW Group is improving energy efficiency of their automobiles, and Toyota is sustainable plants they have. McLaren, they have energy saving tires, and Wave we have self-service bicycle sharing system. And when you talk about iron and steel industry, we have Siemens and ULSAB ABC. So they have, when you talk about Siemens, they have alternative iron making process. And when you talk about ULSAB, they have advanced high strength steel for automobiles. And when we're talking about electronic industry, automotive over iron and steel, now we are moving to the electronics industry. When we're talking about electronics industry, we have IBM, which is working on energy efficiency in data centers, and Yokogawa Electric, where they are trying working on energy saving controller for air conditioning, water pumps, and Sharp, they have enhancing recycling or of electric appliances, and Xerox, they are working on managed print services. So this is what they've explained with the help of the graph on y-axis target and x-axis the mechanism. And this is the companies which are working at technological level, and this is working at the non-technological level. Why? Because when you talk about non-technological, bike sharing is a non-technological one, which depends upon the non. It's not related to the technology. It's related to the persons, how they are sharing. But when you talk about your BMW, Yokogawa, Michelin, they are on technology change. They're trying to have technological innovations in their services and products. Next is modern manufacturing technologies, that is Industry 4.0. So 4.0, Industry 4.0 talks about digital transformation. And when you're talking about the digital transformation, you can just look at here. It's the third platform, innovation accelerators, OT, and manufacturing meeting transformation. And here we have just, you can have a glance on this. So we are here, we have cybersecurity. When you talk about the Industry 4.0, we have cybersecurity, uh, augmented reality, big data, additive manufacturing, system integration, simulation. So you can just look at your simulation, system integration as well. Even we have cloud computing and Internet of Things. So whenever you are thinking about this, it's all about how 3D platforms we are using and OT and manufacturing meeting in transformation. So this is how the industry 4.0 works, and based on this only the industry 4.0 works. And this is a digital transformation that has been taken place, where it is not only used for the individual but also in the industry, because now the big data is like ruling the market, where we need to have big data analytics and big data implementation in the organizations. And from industry 4.4 to fourth industrial revolution, you can just look at here: mechanizations, that is steam engines, and technological electrification. Industry 2 and industry 3, we have computer, internet, digital manufacturing. And 4 is convergence of IT and OT, which are autonomous machines and advanced robotics, big data analytics, internet of things, digital cloud smart factory, machine learning. These all are used in the industry 4.2. So here you can see from automation pyramid to industrial transformation with industry 4.0. So they have given all the four industry, how what are the changes that have been taken place in the industrial transformation from industry 1 to industry 4. And here integration or integrations in industry 4.0. We have industry 4.0 vertical integration, industry 4.0 horizontal integration, and the different components of industry 4.0 are system integration, big data and analytics, simulation and virtualization, internet of things, the cloud, cybersecurity, autonomous robots, augmented reality, additive manufacturing. And you can just look at here, this is the convergence and application of industrial technologies, and which are taking means this according to the Boston Consulting Group, who has given this as which talks about what is the usage and what are the different technologies that are being taking place in industry 4.0, and how the digital transformation that has been taking place in the industry 4.4. So in the 4.0, we have nine technologies, many applications, examples already that exist for nine technologies. If you look at here, when you talk about advanced robotics, we have autonomous and cooperating industrial robots. And when you talk about additive manufacturing, we have 3D printing and augmented reality. Here we can talk about logistics and all kinds of SOPs and simulation. We have your value networks. And when we talk about vertical and horizontal integration, we have cross company data integration, industrial internet. When we are discussing about the next is industrial internet, which talks about network of machines. And when you talk about cloud computing, here we talk huge data volumes on open systems. And cybersecurity, we have operation in network and big data analytics like ERP, SCM. These all are the part and parcel of Industry 4.0. So when we talk about benefits of Industry 4.0, we have increased efficiency in production, more potential for innovation, accelerated response to customer needs, reduced cost and high profit margins, quality assurance, fluid collaboration. So this is how these are the advantages of Industry 4.0. And the challenges when we talk about the Industry 4.0, we have data security, train human resources, and because we cannot rely on the IT management and team support, leveraging data, high cost, and Internet of Things, intelligent robots, additive manufacturing, advanced composite materials. And next we move to the next topic, that is modern manufacturing methods. So in modern manufacturing methods, we have certain principles that are being used in modern manufacturing method, that is waste reduction, product quality, mass production, adaptive control, and rapid prototyping, nano manufacturing, production support systems, computer aided simulations, non-traditional machining process. So when we're talking about the modern manufacturing methods, let us understand it. Manufacturing method is a process of converting raw material into a desired finished product. What actually we will to produce and what actually the customer requires it. Rather than we keeping our own intention, let us manufacture the products which are the customer requires it and which are the need in the market. So here, since the Ford model for production line, there have been many concepts that are developed to optimize all kinds of resources in the manufacturing. So here, the guiding principles of modern manufacturing is three things, that is waste reduction, product quality, and mass production. So here, these are the three principles that has to be used while you're following the modern manufacturing methods. So under that, first one is waste reduction. When you talk about waste reduction, we have the methods like we discussed in the earlier class, like lean manufacturing, just in time, Kanban, just in sequence, total productive maintenance, that is TPM, quick response manufacturing, cellular manufacturing, single minute exchange of die, and the next one is product quality. So here product quality means the product whichever you are producing or providing service, it should be 99.99966% defect free it should be. Then only it is called as product quality. To know whether a product is of quality or not, we have to follow the DMAC, that is define, measure, analyze, improve, and control. The Six Sigma methodology will focus on best basic manufacturing process that are already in motion. And next we have is DMADV, that is define, measure, analyze, uh, and verify. This is nothing but it's an alternative methodology which is used for more anticipatory approach, which is analyze for customer demand, manufacturer plans, and try to design ways to avoid defects in the first place itself, rather than going to the last place or the last production output. Rather than that, it will be finding the defect in the early stages itself. The next one is critical to quality and quality function development, and these two concepts are trying to pinpoint the elements of product that are most important to customers and translate only those which needs manufacturing strategy. And the next one is SIPOC, that is suppliers, inputs, process, outputs, customers. So here the suppliers, inputs, process, output and customers is a diagrammatic tool which will allow manufacturers to trace the life cycle of their products from supplier to customer and also identify problem areas. So here, and even we have Taguchi loss function where it will, if a manufacturer is designs any production plan or which will maximize the product and efficiency, or any sudden changes or variations from that plan is posing any problem, then the Taguchi loss function suggests that production quality decreases as variation increases. So you can just look at here, these are the Six Sigma concepts which talks about how can we implement the modern manufacturing technology methods in the production unit. And the next one is mass production. They always try to have adaptive control and machine flexibility, routing flexibility, computer aided design and computer aided manufacturing, computer integrating machine manufacturing, and adaptive control and rapid prototyping. It's nothing but it includes a variety of manufacturing technologies. Almost it utilize layered additive manufacturing. However, other technologies uh, almost utilize layered additive manufacturing itself. So in this process, it includes subtractive and compressive. Subtractive means they will whereby a block of material is carved to produce the desired shape using the milling, grinding, or turning. And when you talk about compressive, whereby a semi-solid or liquid material is forced into desired shape before being solidified. So here, when we look at this, and compressive stirring and molding will takes place. And the next one is different types of rapid prototyping. So rapid prototyping means this fast and affordable technique was the first successful method of commercial 3D printing, and it uses a bath of photosensitive liquid which solidifies layer by layer. Next, we have selective laser sintering and fused deposition modeling. We have selective laser melting, laminated object manufacturing, digital light processing, binder jetting, and applications. And even we have advantages and disadvantages of rapid prototyping. When we discuss about the advantages of rapid prototyping, it reduces the design and development time, and it also reduces overall product development cost. What are the cost that is involved in the rapid prototyping? That will decreases the cost, and it eliminates or reduce the risk. And it also allows functionality testing, improved and increased user involvement, and ability to evaluate human factors and ergonomics. And when we talk about the disadvantages of rapid prototyping, there is a lack of accuracy and added initial cost. Some rapid prototyping processes are still expensive and are not economical, and material properties like surface finish and strength cannot be matched, require skilled labor, and the range of materials that can be used is limited, and overlooking some key features because it cannot be prototyped, and end user confuses himself because customers mistaking it for the finished product, but sometimes it may not be the finished product. That is misunderstanding that may take place. So then comes the nano manufacturing. Here is a gauge wire made from carbon nanotubes means a product of nano manufacturing, A16 gauge wire, approximately 1.3 millimeters in diameter, made from carbon nanotubes that were spun into thread. So carbon nanotubes are spun into thread, means converted into thread, and with the help of that, the same wire on a 150 ply spool that has been made here. You can just look at the image. So you can look at here, even here also, bipool, ply spool it is, and production support systems. Here, modern production support technologies that contribute to positive mass production, which are automatic conveyor systems, automated guided vehicles, and rail guided vehicles, and industrial robots. So when we talk about PSS, that is production support system, it's a self-explanatory and it's known fact that mass production is economical and practical and profitable in the case of products with high demand. So whenever there is a high demand in the market, so that products can be produced in the mass quantity, in turn which will reduce the cost of production and increase the profitable to that particular manufacturing organization. So the modern production support technologies that contribute to positive mass production are listed below, that is automatic conveyor systems, automated guided vehicles, and rail guided vehicles, and industrial robots. So here manufacturing support systems involve a cycle of information, that is processing activities can be described into four functions. They are business functions, product design, manufacturing planning, and manufacturing control. So your business functions, the business functions are the principal means of communicating with the customers, communicating whenever we want to, it's the main principle, and they are therefore the beginning and ending of the information processing cycle. And your product design is to be manufactured or to customer design, and the design will have been provided by the customer. Next is manufacturing planning. Here the information and the documentation that constitute the product design flow from manufacturing planning function to the production stage. And the last one is manufacturing control. Next we talk about computer aided simulations. With the advent of CAD, that is computer aided manufacturing CAM, and also there is a lot of dynamic changes in the production planning. So software solutions such as CAD, CATA, CATIA, AutoCAD, FEM simulations, etc. These all have been changed the production process and the production planning itself. Next is non-traditional machining and non-machining, that is NTM, non-traditional machining process. So here this can be classified according to the sources of energy that are used to generate, such as machining action, mechanical, electrothermal, chemical, and electrochemical. And under this we have different velocity stream of abrasives or fluids. It is further classified as AJM, that is abrasive jet machining, USM ultrasonic machining, and WJM water jet machining. So these all are the mechanical things that are related to mechanical. Next, when we talk about electrothermal, we have electro discharge machining, laser jet machining. So when we talk these three are working using the technology, the modern technology, and here the thermal energy is applied to very small portion of the work surface, that causing the portion removed by fusion or vaporization of the material. And next is chemical. Here most materials are susceptible to chemical attack. So they use the further source of energy is classified as chemical milling and photochemical milling. Next is electrochemical. It is further classified as electrochemical machining, electrochemical grinding, electrochemical honing, and electrochemical deburring. So next we have sub-process of NTM. Under that we have ultrasonic machining, abrasive jet machine, the same technology is what we are using in electrothermal things that has been repeated here. Laser beam machining, And we have a case study that is of Liverin is a family owned business in a middle town, a small town of around 30,000 people. So you can just go through this case study and try to answer the question that have been given below so that you can have a clear clarity understanding about the technologies, how it's been used in that family. Uh, Next is automation and robotics. Its meaning and reasons for automation. In this automation and robotics, we try to understand what is automation and robotics, its meaning, reasons, advantages, disadvantages, types of automated manufacturing systems, uh, what's the need for using robotics in industries, laws of robotics, anatomy of robots, types of drive systems, robotic sensors, specifications, and robotic application in automotive manufacturing, its application in space, how robots are used in space, and its application in space, medical and defense, its advantages and disadvantages. So here, whenever we are going through the manufacturing process of various industries, we try to choose the automation only to improve the quality and its boost productivity and save labor cost. And manufacturing companies which are integrated and using multiple forms of robotics, conveyance, vision, or other automated technology to complete production tasks. So, whenever we talk about industrial automation and robotics, we are using the computers, control systems, and information technology to handle industrial process and the machinery. And when you are using the computers, control systems, and information technology, for handling the machines means we are replacing the HR, that is labor, to improve the efficiency, because when you are replacing the labor with machines, automatically the efficiency is going to increase, speed it's going to increase, quality and also the performance of the machines is uh, far more better than the labor. But when automated industrial applications are ranging from manufacturing process, that is from assembly lines to surgery and space research. So when it started, early automated systems focused on increasing productivity, but this focus is now shifting to improved quality and flexibility in manufacturing and more. So what is the, because automation and robotics have areas where they cross each other, like such as the use of robots to automate physical tasks like car assembly lines, where the working of human labor is less efficient when compared with the automation. So when car assembly lines are taking place, their automation is playing a very crucial role in that. And meaning and reasons for automation. Automation is the technology by which a process or procedure is accomplished without human assistance, and it is implemented by using a program instructions and combined with a control systems that we are going to execute the instructions. And to automate a process, power is required both to drive the process itself and to operate the program. What are the reasons for automation? Only to increase labor productivity, rather than, because instead of using human or labor, if we are replacing the automation, we can have less number of labor and production increases, and also to reduce labor cost, to mitigate the effects of labor shortages, to reduce or eliminate routine manual and clerical tasks, to improve worker safety, to improve product quality, to reduce manufacturing lead time, to accomplish process that can be done manually, and to avoid the high cost of non-automating. When we talk about the disadvantages, we have less variability. Why? Because when by having a machine that can perform certain tasks, limit to the flexibility and variety of tasks that an employee can do, the machine cannot do that. So that is one of the disadvantage. Next is more pollution. Why? Because different types of machine which are operate using motor that will give release gases, or it will require gases or chemicals to in order to operate it. So that is also one of the disadvantage, that is more pollution is going to create it. Next is large initial investment. In this, automated machines can be one of the mostly operating costs for a company and increase in unemployment. So these are disadvantages of automation. And why? Because when you are going for the automation, it's automatically replacing the labor. It means when labor are removed and replaced with the machines, it's automatically decrease the unemployment, or it is going to increase the unemployment because we are removing the labor. So there will be a lot of unemployment in the nation. So when we talk about disadvantage of automation, we have four disadvantages, that is less variability, more pollution, less variability. This is the one disadvantage. And the next is more pollution, large initial investment, because when we are replacing the machines, automatically when we are replacing the labor with machine, it's a large investment, and increase in unemployment. So now what are the types of automated manufacturing systems that are existing in the manufacturing industry? So that we will continue it in the next class. Thank you all.